once again, we welcome you to the Great American Coin and Collectibles Show here in Tampa. A great opportunity for many of you here, and we're going to have our first educational presentation. And with this, the new generation of trade shows, one of the innovations we're trying is to keep the educational activity on the Bourse floor or near the Bourse floor. So if you haven't made your way around the complete Bourse floor yet, you'll find that the stage is going to be located in the 1600 section, right between the Mint and the Coin World booth. And that's where we're going to have this first presentation. There will be several presentations over the week. Our first presentation is by error specialist Mike Diamond, the writer of the Collectors Clearinghouse column for Coin World, and he's going to give us a presentation today entitled One Hand Clapping, How Some Errors Sidestep Newton's Third Law of Motion. Now, I don't think many of you know all about that, so here's your chance to learn a little bit more about that. Without any further ado, let me introduce to you Collectors Clearinghouse columnist, error specialist, Mike Diamond.
Hello, I feel I'm coming in now. Welcome. I wanted to talk today about a category of errors you might not be familiar with. If you have questions during the talk, feel free to shout them out. If you have questions after the talk, again, feel free. We're not especially time limited. All right, one hand clapping. Newton's third law of motion states that for every action there is an equal and opposite reaction. We therefore expect that when a die-struck design appears on one face, resistance has been applied to the opposite face. That resistance typically comes from the other die, either directly or transmitted through objects interposed between the die and the planchet. Signs of resistance would obviously be a die-struck design on the other side, heads and tails. Could be a blockage, the incuse mirror image impression of a coin interposed between the die and the planchet. An indent, the impression of a planchet, or some kind of struck-through error. Resistance from sources other than the opposing die is unusual and unexpected. Even more unexpected is a die-struck design that lies across from an untouched area on the opposite face. This implies the absence of resistance and seemingly violates Newton's third law of motion. After all, a one-sided strike is analogous to one-hand clapping. But some types of errors manage to sidestep Newton's third law without actually violating it. Obviously, you cannot have a strict violation. One cohort of striking errors that performs this trick is the stutter strike, something you may not have heard of. A stutter strike features a narrow crescent of die-struck design on one face that lies lateral to the main design and across from an unstruck surface. While it looks like an additional strike, it is not. There are three types of stutter strikes generated by distinctly different processes. Type 1 stutter strikes only appear on the face struck by the hammer die, which, depending on the die setup, could be the obverse die or the reverse die. The resistance to the impact of the hammer die is provided by the collar and nothing else. All type 1 stutter strikes are associated with uncentered broad strikes or off-center strikes. This 1999P nickel shows a type 1 stutter strike on its reverse face, which was struck by the hammer die. You can see the letters of America right here. Looks like an additional strike, it is not. A type 1 stutter strike requires three starting conditions. A slightly off-center planchet in which one pole rests on the elevated collar. The planchet is consequently tilted up at that pole. A collar that resists depression, i.e. a stiff collar error. This is the source of resistance to the initial impact of the hammer die. The third ingredient is an unstable hammer die or die assembly that begins its descent and first contacts the planchet in a misaligned position that lines up with the protruding pole both vertically and horizontally. And there's going to be an illustration. When the misaligned hammer die first contacts the planchet, it leaves a thin crescent of die-struck design on the elevated pole. As it continues its downstroke, the hammer die jumps medially, reestablishing a centered position. It completes its downstroke in a properly centered position. The original die-struck crescent is left marooned beyond the vertical plane of the definitive design on the opposite face. And here's the diagram. Here's the hammer die, which is misaligned, vertically aligned with the collar and with the off-center planchet. It strikes this area first, and as it descends and meets resistance, it jumps to the left, in this case, reestablishing a centered position. Given the number of starting conditions required, Type 1 stutter strikes are understandably rare. However, the coining press that struck the illustrated 1999P nickel produced quite a few examples, along with hundreds of uncentered broad strikes and minor off-center strikes that lack a recognizable set of extra letters. They do show what you might call a double rim effect. And so you can find this on other stiff collar errors, this double rim effect, but it's rare for the die to be so misaligned on first impact and move so far to the other side during its final descent that you actually get a distinct set of letters. I do have $1/4 that shows a nice example, although it's not in this lecture. None of the grading services recognize the existence of Type 1 stutter strikes. Clear examples are usually labeled as double strikes, while minor examples that just show the tips of the peripheral letters may escape notice entirely. The latter end up simply being called broad strikes or off-center strikes. While the formation of a Type 1 stutter strike depends on resistance from a stiff collar, a Type 2 stutter strike forms without any resistance at all from the opposite face. Instead, it owes its existence to a rapid flexing of the planchet during the strike. The resistance is provided by the coin itself. As is the case with Type 1 stutter strikes, Type 2 stutter strikes are confined to the face struck by the hammer die. They are always struck out of collar and only occur in association with a partial blockage, indent, or struck through error at the opposite pole. Here's an example of a Type 2 stutter strike. Another 1999P nickel, guess it was lucky that year. There's about a 40% indent from an unstruck planchet on the left side, the definitive strike in the middle, and a narrow crescent of die-struck design on the right. That is the stutter strike. A Type 2 stutter strike develops when a coin is partly overlain by a coin, a planchet, or a relatively thick foreign object. The area beneath the intrusive object is struck first and expands in all directions. This expansion pushes the unstruck portion of the planchet away from the intrusive object. At the same time, the unstruck portion of the planchet tips up toward the hammer die. It makes brief contact with the descending hammer die before being pushed beyond the limits of the striking chamber. The continuation of the hammer die's downstroke generates the definitive design. The faint set of peripheral elements left by initial contact with the hammer die lies within a narrow crescent situated across from the planchet's unstruck perimeter. And here's a diagram of what happens. We've got immediately below the hammer die an intrusive planchet intruding partway into the striking chamber. Below that, a properly centered planchet. As the hammer die descends, it squeezes the double thickness on the left, forces the right side to tip up, It makes brief contact with the peripheral part, right part of the die on the right, and then as the hammer die continues pushing down and squeezing, that part of the coin is pushed out of the striking chamber. While indents, partial blockages, and struck-through errors are relatively common, Type 2 stutter strikes are quite rare. I have maybe 4 decent examples in my collection. I've seen others, but they were priced too high. So they're rare. However, scuff marks generated by the same process that generates a Type 2 stutter strike are often seen at the pole opposite any kind of indentation. Type 2 stutter strikes are not recognized by any of the grading services. Clear examples are categorized as double strikes, even though only one strike is involved. Subtle examples will escape notice. Type 3 stutter strikes are the most variable of all in terms of formation and appearance. They occur in association with planchets or previously struck coins that are bent, crumpled, or torn. They are also necessarily associated with broad strikes and off-center strikes. Unlike the previous 2 categories, Type 3 stutter strikes can appear on either face. Here's an example on an edge strike. This 1998 cent arrived in the striking chamber on edge, either spinning on edge, rolling across the striking chamber on edge, flying through the striking chamber and being caught on edge. It'll vary, but it was caught by the dies on edge and then started bending. It fell on its side in its bent condition. And it stood on the tips of its concave reverse face. The convex obverse face faced towards the hammer die. As the downstroke continued, the hammer die contacted the convex surface, flattening it and pushing the initial area of contact beyond the striking chamber. This left the ST of truss from the initial contact lying beyond the definitive truss and across from an unstruck reverse surface. So this is kind of a diagram of what happened. It was struck on edge, bent, fell on its side with the tips of the arch resting on the anvil die. Hammer die continued pushing down, flattening it out, and I guess it would be off the screen, the area that was first contacted by the hammer die was pushed out of the striking chamber, leaving that little bit of ST. In this Type 3 stutter strike, resistance to the initial impact of the hammer die was provided by the sides of the arch created by the bent edge strike. The base of the arch transmitted the resistance from the anvil die, which in this case was the reverse die. Here's a Type 3 stutter strike on the reverse face. This off-center dime was struck on a torn planchet in which the 2 flaps overlapped each other. The flap that was resting on the anvil die received a weak reverse impression, the word 1, during the early phase of the hammer die's downstroke. As the downstroke continued, the 2 flaps were forced to lie edge to edge, while the outermost portion of the lower flap was pushed beyond the striking chamber. As a result, we have a weakly struck version of 1 lying next to the definitive 1 from the completion of the downstroke. Now this is more or less what happened. 2 torn flaps lying across from each other, hammer die comes down. We get an initial design forming here. As they continue to be squished, this flap gets pushed out. In this Type 3 stutter strike, resistance to the initial impact of the anvil die on the outer face of the lower flap, the lower face in other words, was provided by the overlapping upper flap. The upper flap transmitted the initial impact of the hammer die to the lower flap. Squeezed beyond the striking chamber, the original 1 lies across from the unstruck portion of the planchet. Type 3 stutter strikes are quite rare. it should come as no surprise that they are not recognized by any of the grading services. Once again, prominent examples like our dime are likely to be labeled as double strikes, while less obvious examples like the 1998 edge struck cent are overlooked entirely. Any questions at this point? Yes.
And, oh, okay. The planchets are received in between the anvil and hammer die. They're at a fairly high temperature.
Arrive at essentially room
So
temperature.
oh, really? And then the anvil.
I mean, there is some heat generated by the compression of the planchet, but it doesn't amount to that much.
So, okay.
This is all cold forming of metal.
Okay, because I would think that you would need to soften the planchet so it would take the full design.
No, we're dealing with many tens of tons of force applied to
Okay.
metal. That is going to exhibit plastic deformation even if it's cold.
Okay,
So all coin designs emerge as a result of cold forming and plastic deformation.
are Janiver machines still in use?
Janvier?
Yes.
No, they're no longer used.
What do they use today?
Now they cut the design with, the design is created by, what do you call it, on a computer, and it's translated to the die with engraving machines. They no longer have to shrink the design. They're cut into the master hub directly.
Okay. Thank you.
Sure. All right, another area in which a die-struck design forms opposite an unstruck surface is the extrusion strike. Extrusion strikes develop when coin metal bulges into a gap, with the apex of the bulge contacting the exposed portion of the die hovering above. The area opposite the bulge simultaneously withdraws from the other die, forming a featureless pucker. Most extrusion strikes involve coins that are struck in collar, although there are exceptions. Extrusion strikes can form in several circumstances. Metal can bulge into the gap between two overlying or underlying planchets. This scenario requires an out-of-collar strike. Basically, you have a planchet, two other discs on top with a gap between, and the metal is going to be forced up between that, forced into that gap. Second scenario can be forced into the gap between a curved clip and the collar. That's what I'm going to be illustrating in a moment. Into the gap formed by a rip in a die cap, into the recess formed by a retained cud and the collar. That's actually fairly common. And through the center hole of an isolated bimetallic ring. At this point, that's purely theoretical because I haven't seen it yet, but it would be cool to see. Here's an extrusion strike. This 2010 India 5 rupees coin was struck through a planchet with a curved or concave clip. Coin metal from the intact planchet bulged into the gap between the clip and the collar. You need the metal confined in order for it to bulge. If it was an out-of-collar strike, it wouldn't work. The apex of the bulge contacted the obverse die, leaving it with which was the hammer die, leaving it with the die-struck letters I and D from India and part of the Ashoka lion, which is the national symbol of India. Coin metal withdrew from the reverse die, which was the hammer die, leaving this area with a featureless pucker. There are domestic coins with this kind of error. I've seen it in dimes from the late 1990s, maybe 2000, maybe one nickel. In an extrusion strike, resistance to the impact of the die is generated by the coin itself. The rapidly rising bulge, propelled by surrounding compressed and expanding metal, pushes into the die with enough force to generate a die-struck design at the apex of the bulge. So in this kind of error, the die isn't striking the coin is striking the die. Grading services do not recognize extrusion strikes as a distinct category. like the other errors described here, it can be considered an effect rather than an independent striking error, but that's true of many striking errors. And we'll finish up with another category. A very weak off-center strike may be detectable on only one face. In some cases, the resistance is provided solely by a stiff collar. This 1992 P quarter received a very weak 75% off-center second strike. The second strike obverse design is restricted to the first strike design rim, right here in the upper left quadrant. On the reverse, the only evidence of die contact is a second strike design rim that crosses the first strike design rim at 2 points. Right here, right here. I'd use a laser pointer, but it's not working today. Almost all the resistance to the second strike was provided by the collar. It is therefore similar to a type 1 stutter strike where resistance is also provided by the collar. So collar resistance can be seen in a facet here and a facet over there. Oh. Well, that's all the eye candy I have to show. Are there any questions? Any further questions? Okay. Guess we're done then.
Thank you, Mike. Appreciate that. Mike Diamond, once again, providing us with the information here. Mike is going to be with us at the Great American Coin and Collectibles Show for another day tomorrow. He'll be at the Coin World booth on occasion. So if you have any questions regarding any other types of errors, anything errors in particular, we invite you to stop by at the Coin World booth at the 1600 aisle, and you can get some information. But thank you for being a part of the first educational program for the Great American Coin and Collectibles Show. We'll be back with some stage activity coming your way at 3 o'clock. In the meantime, enjoy day one here at the Great American Coin and Collectibles Show.